Hi everyone. This is a tutorial for PTV's VISTRO software. So VISTRO is a software package that PTV offers to basically implement the methods of the highway capacity manual or um, other deterministic methods. So deterministic essentially means that it is a mathematical model which produces the same result every time, as opposed to a stochastic model like VISM, where there is a degree of randomness and you can get different results with each run of the simulation. You may also have heard of VISTRO, or not VISTRO, sorry, SYNCHRO. Um, SYNCHRO is an almost identical software package to VISTRO, but here at the University of Waterloo, our computers have VISTRO instead. Although in industry, to my knowledge, SYNCHRO is much more commonly used, but they're essentially the same software. So the way VISTRO works is you have two sort of sections of the screen. On the left here, you have your sort of map visualization of the intersection. And up here in the top right of that half, you have different layers on the map that you can control. So one layer is your network. So really quick, if I just add an intersection to the network, we can toggle the visibility of that layer on and off. We can also adjust the transparency. And we also can have a background layer, which will probably show up on your computers as internet map. So you can toggle that on and off, of course, but you can also pick from different map types. So on my computer, I only have access to these PTV maps. They give you a couple different styling options. But on some computers, you might have access to a Bing map. Unfortunately, I don't. But if you do have access to Bing maps, then you should be able to get a satellite background. And that's really useful because then you can match what you're building in the software to the alignment, to the exact alignment of the road network. But for me, I'm going to stick with PTV's maps and go ahead and make an intersection. So, still on the left side, on this left toolbar, we have a number of different options. The top half here is dealing with network construction. The top button allows us to quickly place different types of intersections. So by default, if I click on it, it will give me a signalized intersection, but there's also options to have stop controlled intersections, roundabouts, etc. We're mostly just going to be using that button. These other buttons here are more for traffic impact analysis, which is another area that this software is very useful for, but I don't think we're going to be covering it in these tutorials. In the bottom here, we have different data labels and layers that we can turn on and off. So we can choose to show our turning movement volumes. We can show signal groups. We can show the level of service of each movement. And we can show multiple of these as well. Now right now it's not showing level of service because we don't have any analysis yet, but we'll get to that later. We can also show the intersection number, road labels, but we haven't entered any of that in yet, so we'll get to that later. On the right side here is where we're going to do most of our actual input, and it's also where the calculations for the intersection will appear once we've inputted all our data. So here there's a couple different groups. We're mostly going to be focusing on these three here on the left. So intersection setup, that's mostly the geometry of the intersection. And then we'll talk a little bit, and then we'll move on to volumes, so inputting volumes and turning movement counts, and then inputting our traffic control information, so signal timings, stop control, stuff like that. And you can see it's kind of laid out in the order that PTV wants you to do it. And this is also the logical order to do it anyways, which is really nice. Before we get into that, I just want everyone to just check a couple things on their computer. We're going to be doing everything in metric today. So what you need to do is you need to go up to global settings here and just make sure that your units are set to metric. Mine are by default set to imperial. So we're going to change that. There's also a bunch of other global settings in here that we can change if we want to. But for today, I don't think we need to change any of them. Yeah. So just change your units to metric because we're going to be measuring everything in metric, and all of our inputs will be in metric today. Okay. So without further ado, let's create an intersection. So we're going to just quickly kind of create a basic intersection here. And the one I've chosen to do is Columbia and Phillip Street. So if you're watching this from the University of Waterloo, this will be an intersection that's probably very familiar to you. If you're watching this from elsewhere, it's just your typical signalized intersection. So what I'm going to do is I go to the top, I click signalized intersection, and then I just click again where I want to place the intersection. And once the intersection is placed, we can use these dots so if we click on the dot in the center, it'll move the entire intersection. If we click on the dots at the end of each leg, we can extend the legs up and down. So I'm just going to extend these so that they match roughly the geometry. And there we go. We have a simple four-legged intersection. Now, most of our inputs can be done on this right panel here. So first we can give our intersection a name. So I'm going to call it Columbia and Phillip. We can add in any notes. Our control type will be signalized. Our analysis method, so VISTRO gives you a number of different ways you can analyze the intersection. Most of the time you'll be working with HCM, so Highway Capacity Manual, and which edition or year you pick depending on the situation, it's either up to you, or if you're doing a study in the real world, it might be prescribed to you by the reviewing municipality. But for today, we're just going to leave it at the most recent edition, which is the HCM 7th edition. And now we can input our information for each leg of the intersection. So we're going to start with the northbound leg, and you'll notice that when I click on cells in the northbound leg, it gives us a little box down here on the map that shows that we've selected and are actively editing that leg. So I'm going to give our northbound leg a street name, which in this case will be Phillip Street. I'm going to do the same thing for southbound. That'll also be Phillip Street. Eastbound will be Columbia Street. And same thing with westbound. And then there's just a row here. We can check this off if we want the street name to appear. Now you'll notice it's not appearing yet, but it will appear when we activate the street name layer here. So I think I'm just going to leave that on for the rest of this. The next part is we have to deal with the lane configurations of each approach. Now, if you have Bing Maps enabled, like I said earlier, what you can do is you can either turn your network layer off to see what's underneath and look at the satellite picture of the lanes and try to match those, or you can adjust the opacity of of that layer and then look at each approach. Unfortunately, I don't have the satellite image, so I'm going to have to use Google Maps here on the side. So I'm going to use the Google Maps satellite view, and we're just going to go through each approach. So starting with the northbound approach, we can see here that our lane configuration is basically we have one lane that's a through right lane, and we have another separate left turn lane. So I'm just going to select that. And VISTRO gives you a number of preset options. So in this case, that's a very common configuration. So I can just click here and add that. But if we had a more custom configuration, say there were 2 left turn lanes, we can click on this green plus to add some left turn lanes. We can also add other types of lanes as well. But for what we need today, we just need the single left lane and the through right lane. And you can see that once I input it there, it will update. I'm going to do the same thing with the southbound approach, which I believe it's the same configuration. And while I'm here, I'm just going to look at the east and westbound approaches. So for the east and westbound, they're both the same. We have a single through lane, a through right lane, and a dedicated left turn lane in both directions. So I'm just going to add all of that in. And these are all very common configurations, so they're in the preset menu. All right. The next step here, these are all broken down by turning movement. We're not going to input the volumes yet. We can do that later at the volume stage. We're going to focus right now on the geometry. So the next thing we want to do, you'll notice by default here, the left turn lanes, they have a pre-assumed length. That length is always the same, and I'll just turn off the labels here so you can see that more clearly. So they're all the same length. As you can see, if you're looking at Bing or Google Maps, these left turn lanes are not all equally long. So we're going to have to make that slight adjustment. So the way we can do that is we can define the number of lanes and the length of lanes in the entry pocket. So number of lanes, if we add number of lanes here, because we've already said there's a single left turn lane, we can't really adjust that. So we're going to leave that at 1. But for the pocket length, we can adjust that. So typically, I've seen people do one of two things when it comes to measuring the pocket length, or sometimes we call it the storage length of the left turn lane. Some people will measure the entire length of the left turn lane like this, right from where the taper begins all the way to the stop bar. Other people will measure just the part that is actually wide enough to store a full vehicle. And that's what I'm going to do. That's personally my preference, just because it tends to be a bit more conservative. And I'm just going to round roughly to the nearest meter or so here. So for the westbound approach, that would be 35 meters. For the northbound approach, you can see that here there's not really a taper, so I'm going to go right to where the left turn lane becomes part of the median. So that'll be about 38 meters. I'm just going to put those in while I'm still thinking about it. And for our eastbound approach, I'm going to measure all the way up here. You can see that usually the full width of the lane starts where the solid line is. So that's another cue you can look for. So that's going to be, I'm going to call that 114 meters for the eastbound direction. And I'll just quickly measure the southbound. I'm going to call that about 30 meters there. And so those are the main adjustments we need. You can see that for some of these, it's actually the storage length of our left turn lane is actually longer than what was available, or with what is displayed, I should say, on the map. So for the eastbound approach there, we just had to extend that a bit so we could see the whole thing. Yeah. Oh, and as a side note, if you haven't noticed already, I'm panning around using the scroll button on my mouse. Okay, so now we've dealt with the entry pocket, which is basically another word for turning lanes. There's also the option here for what they're calling an exit pocket, and that's basically lanes that end soon after the intersection. So if I were to define one for the northbound approach here, so this approach, what you'll see is that it creates a lane which ends just after the intersection. And that might be useful in some cases, but in this case, as you can see, we don't have any of those lanes to deal with. So I'm just going to set it back to 0 for all the approaches. As well, we can toggle medians on and off. For these approaches, I don't think we have any medians to deal with today, but that's just something to know. You can also adjust the length and width of the median, but again, we don't need to do that. You can also adjust, so if you have, this is not the case here, but if you had an approach where, say, this leg was a bit offset from this leg, so in other words, it was moved a little bit to the right or to the left, we could adjust that here. So we can, if I set a 5 meter offset, you can see it moves 5 meters to the right. You can also adjust the speed. To my knowledge, each of the roads here has a speed limit of 50 kilometers an hour, which is the default in VISTRO. You can adjust the grade of each approach. In the absence of the grade or any of these other measurements that you can see here, so curb to curb width of the crossing, whether there's a curb, the width of the sidewalk, in the absence of a site visit where we can go out and measure all of these things in detail, we're just going to leave them at their default values. And then down here, you can toggle crosswalks on and off. You can define the width of a crosswalk. In this case, again, I haven't been out to the site to actually measure it. So we can see that there's 4 crosswalks, and we're just going to leave them at the default width. So all crosswalks will be checked, and we're just going to leave it at that default 2.5 meter width. You can also adjust the setback, the length of the crosswalk. Again, we don't have measurements for those, so we're not going to change them. So after doing the crosswalks, you can define whether or not each approach has channelized turns, channelized right turns. So you can do that using this checkbox here, and you'll see it creates a channelized right turn off to the side. You can adjust a couple things about it. You can adjust where the crosswalk is located. You can adjust the number of islands. You can adjust whether there's a target lane that the channelized turn has to merge into. And you can, most importantly, you can also adjust the controls. So sometimes, most of the time in Ontario, you see a channelized right turn and there's a yield sign. Occasionally there'll be a stop sign, or occasionally there'll be no sign. It's very rare to my knowledge that there's a signalized control for a channelized right turn, but regardless, VISTRO gives you the option. But in this case, we don't have any of that to deal with. So we can move on to the volumes.